Hello, let's continue our Sudoku adventure with The Chaos is That Way by Sanabas. So we actually are chaos construction. This does continue our irregular theme week, and chaos constructions are technically also irregular Sudokus. So let's go over the rules. I'm allowing Sanabas to stretch the theme a little bit on that one. Um, anyway, let's go over the rules. So we have chaos construction 6x6 Sudoku rules. So in each row, each column, we're placing the digits 1 to 6 once each. And there's also like hidden regions in the grid. The regions are connected orthogonally, meaning they share an edge. So like this is connected orthogonally. This is not. This is not orthogonally connected. Like we can't just like sprinkle that way. We definitely can't just like make an isolated island over here that happens to be the same region as that. They have to be connected. And we're going to be just filling the grid with some number of irregular regions. Oh, with exactly 6 regions of 6 cells each. So something along these lines probably would work. I doubt this is the solution though. And so within each of these regions, we are placing the digits 1 to 6 each, but it's up to us to follow the rules and logically deduce exactly where all the regions are in addition to solving the Sudoku. We're going to need to do so in order to solve it. All right, so what else do we have going on here? Just chaos construction arrows. So the way these arrows work is whatever digit goes in there, say this was a 3, then you count 1, 2, 3 away, and that plus those cells are in the same region as the arrow. So if this was a 3, all of these would be green. And then that's telling us that then we have to start a new region. We'll call that purple. So I recommend opening up your settings if pen tool is not enabled at the very top, enabling that. Then you have a new tab for pen tool. I would change it to edge only for this puzzle, and then choose black is usually a good idea. And you can draw where your region borders are, where you know that the regions don't cross. And you can also do the whole border outside so it kind of matches. All right, and that's it. Those are the rules. There's a link in the description if you want to try the puzzle yourself, and I'm going to get started right now. Okay, so one of the kind of things I want to think about is what digits are actually possible on an arrow. So first of all, we can't put a 0 on an arrow. So kind of the most obvious deduction is we're at least 1 in every arrow, which means every arrow uses, or is in the same region as at least the one it's pointing at, the one directly sharing an edge with it in the direction it's pointing. So why don't we start here? This is in the same region as all 3 of these. So we'll call that the green region. This one's in the same region as these 2. Now it can't be green because already it would add to 7 and it has to bridge the gap in addition to that. So that's a new region. What about this one? So by the time this one reached up here, we would also be size 7. So this is a new region, and it takes that one, which then takes that one. I'll do digits in a second. I want to look at these arrows first. Maybe this one. This one definitely can't join the green, so it's a new one. We'll call that red, and it takes that one. This one could be red, or it could be a new region, so I can't color that one yet. So we'll just have to remember it takes both of those. This one, is this a new region? I mean, red could take it. I believe. It would have to do this. This would be 1, this would be 2, but it would work. So we don't know the region for that one either. So we have 4 regions to find that are definitely different regions. And then we have these arrows that we're not sure yet. Okay, let's think about numbers. So we can never put a 6 on an arrow. That's definitely true. And more generally, you can't go off the grid. So, oh, right. I want to bold the grid so it looks better with lines I make. So this one here, it can grow up to 3, but then it hits purple. So that's up to 3. This one, can it actually be a 2? Yeah, because we could just do this and we'd end up with this nice 6 cell region. This would be 1, this would be 2. That would be okay. So this is 1 or 2. This one, I'm avoiding the double arrows until I do these easier ones. This also goes up to 3. Could it actually be a 3? I don't see why not. At least not at the moment. All right, let's do this double arrow then. So 1 definitely works. That's what we've drawn out. Does 2 work? 2 would take this one and this one. 1, 2, 3, 4, 5. Yeah, and then we could bridge the gap. So that works, but 3 definitely won't work. We would take all of these, we'd have to connect these up and is already more than 6. So 1 or 2. So that's a 1-2 pair. That places the 3 here, which does mean that these are all orange. I still want to think about these other ones. So does that mean this can't be 2 anymore? Because if this was a 2, we'd take this one, and that's our 6th one for orange, and we're not connected. So this is a 1. So we know this one, I'm going to mark it gray because I don't want to think about it yet. But we know this one isn't orange. In fact, orange is going to have to grow only 1 more digit. So this one's not orange. Because if this one was orange, this could not be orange because orange would be 7 in size. It's already done at that point. But it can't be a 6 cell region. So it wouldn't be in a region. That's bad. So this, I guess that means gray is a new region, isn't it? This one can't be orange and it has to get out. So we'll call this the yellow region. So we only need to find the blue region now. So either this is orange or one of these is orange. Okay. Let's think about this one. Oh, sorry, this is a 2 now, actually. So these are all purple. Okay, so we know that the 2 means we end here. We also end here. We weren't going to take that anyway. We're not going to expand to this way because we need to connect up, and connecting up will finish us either here or here. So one of these is purple. Okay. This one, I mean, it can't be a 2 anymore. Could it have ever even been a 2? I feel like no, because we only get 2 more cells, and that adds 3. So I think this was 1 from the start. I wanted to think about it last. And so that means that we have to end here. We have to end here. And whatever this is, I'm going to use gray again just to represent that this cell here is not green. Interestingly, this cell here isn't green or purple. And so it's got to be the blue region because it can't reach anything else. And so it's got to get out, which means that that is not green. And so that means gray isn't green. And blue has to continue getting out. Even if it took all 3 of these, it would have to go 4 here. And green gets out this way, so we can draw a new border. And so this still has to get out. It's only 4. It has only one way out, so it's going to take that. And this arrow here at least takes this one, so it has to be blue, which then forces it to be the 4. Okay. That was nice. That was a lot all at once. We know this one's not green because of the 1 clue. That's what this border was telling us. And so green can only finish here. These 2 can only reach red, so they are red, and that makes this a 3. Okay, so 3 has 4 digits. 3 has 4 digits. Red has 4 digits. Red has 4 digits. It needs 2 more, and it's only going to get them from here. So we know that these 2 are in the same region as each other, and so that's gonna have to be red. Because if it were a different one, red wouldn't have enough cells. So we're going to draw that border. Red is done. This can only join blue, and that finishes blue as well. This one can only reach purple now, so it's going to be purple. Yellow could take this one, but it would be 1, 2, 3, 4, 5, 6. So these are always yellow, and either one of these is yellow, one's orange. But I think Sudoku is going to have to resolve that for us. Let's draw the borders that we can, because why not? All right. Sudoku, I guess. Nice. We have almost all the regions. Oh, I didn't fill this arrow. This is a 2. That places 2 in blue. Did I miss any other arrows? No. Glad I reminded myself, hey, there's arrows. Oh, 2 in this region goes here. Oh, orange is going to need a 2. And it can't put it here. Okay. So orange is going to have to grow to get the 2. And this is the only cell that can be 2 that can grow 2. Of the 2 possibilities. So that actually finishes that. And that's our 2. So I'm trying to avoid penciling until I have to. 3 in this region is one of these 2. I may have to pencil. Okay. Well, there's 1 in this column. It can't repeat in green, so the 1 goes here. Then 6 looks down, so that's 6 and that's 4. So this is 1, 2, 3. This can't be 2 or 3, so that's 1. This can't be 2, so that's 3 and 2. 5, 6 here. 5, 6 here. 4 in this region can only go here. Oh, I didn't draw this border. Gosh. Sorry about that. Must have been bugging you. 5, 6 pair here, and here, and here. 4 can only go here in this row. This is another 5, 6. So these are 3, 5, 6. Penciling would make quick work of this, I'm sure. 3, 5. Oh, this 5 looks up. There we go. That's 6, that's 5. So that's 5 and 6 and 5. Nice. 5 looks up, 5 looks in, 5 goes here. What about 1? Yeah, 1 is placed. How about 3? 3 is placed, 4 is placed. Here I need 1, 3, 6. The 1 can only go here. This is 3, this is 6. And finally we need 3, 5, and 6. So that's 5. That's 3. That's 6. Nice, I didn't have to pencil. I mean, I penciled early on the arrows, I guess. All right, cool puzzle, Sanabas. I enjoyed that. Yeah, maybe this was probably where you intended us to start. It was in the top left corner after all. But I just wanted to train myself on how the arrows worked before I tackled what seemed like the harder one, but actually ended up being the easy one because it could only be one. But I got there eventually. All right, well, how'd you do?